Today, we're going to be talking about extraction in coffee brewing, and we'll talk about what it is and how to measure it. But most importantly, I think we're going to find that just knowing how to calculate extraction yield will help us learn how to improve our coffee, whether or not we decide to measure it every time we brew coffee. So stick around. Welcome to the Virtual Coffee Lab. This is a series on brewing coffee and how it relates to roasting and tasting. And last week we talked a little bit about what is brewing in general. You can click here to see more about that. But ultimately we said that brewing is the process of taking coffee grounds and using water to extract the compounds that are in coffee so that we can taste, drink, and enjoy them. So today we're going to talk about a common measurement that is used in brewing coffee to measure that whole process of taking compounds out of coffee, and that is called extraction or extraction yield. So you have probably seen people online, they'll say, oh, I had a really great cup of coffee, it was a 20% EY or 20% extraction yield, and that's the number that we're going to be talking about. So I just want to make the case for tracking and understanding this type of number before we get into the details. And first off, I want to say is that if you're familiar with coffee roasting, like a lot of people are in this channel, there are all sorts of things that we take note of and measure and calculate when we roast coffee. And those things help us to understand what has happened during the roast and to help us correlate that to what we experience when we're consuming it. So just like with that, but with coffee brewing, there are certain things that we might want to measure or track with our brewing to understand how the brewing process is going to impact our experience and how that experience relates not only to our brewing, but to our roast of that coffee and all of the other details about that coffee, like where it was grown and what variety it is. So, how to calculate extraction yield? There are three numbers that you need to calculate extraction yield, and that is the weight of the final brew, so how much the brewed coffee weighs, the TDS of the brew, total dissolved solids, and the weight of the coffee grounds that were used before you got them wet. So those three numbers. And how you calculate it is you take your brew weight and you multiply it by the TDS, and then that is divided by the weight of the coffee grounds. So it's a pretty simple calculation to do. So I just want to make a note real quick about TDS. TDS means total dissolved solids, and that's a measurement that you need to take with a tool called a refractometer. You can buy a really inexpensive refractometer on Amazon for $20. That's completely manual. But most people who have refractometers and are using them with coffee use a digital one, and that starts at $300 and goes up to $900. But the important point that I want to make here is that to benefit from understanding how extraction yield is calculated, you do not have to buy a refractometer and measure this yourself. I think as we talk about what these numbers mean and how they change with brew variables will be enough to inform some of the decisions that we make when we're brewing. Let's imagine that you've taken your measurements, you've gotten your calculation, and you have your number, and it's like 19% for your brew. So let's think for a moment for how this number can be impacted by brew variables when we think about that formula that I mentioned earlier. The first thing that you notice is that all else held equal, if we increase our TDS, we will increase extraction. That means that having more coffee compounds in your cup will register a higher extraction number, all else being held equal. But what's interesting about this formula is that if both your brewed coffee weight and your TDS increase, extraction isn't going to go up that much. And what that means is that we want to get a sufficient TDS without using a ton of coffee grounds. If you use a lot of coffee grounds to reach the TDS that you desire, then really you're just getting an under-extracted cup, meaning you're getting some of the coffee solids from a whole lot of coffee into your cup. So that's the important thing to take away. A strong cup of coffee, high TDS, does not necessarily mean that you have a high extraction cup of coffee, which is counterintuitive because normally if we taste a very strong cup of coffee, we might think, yes, that's high extraction, we got a lot of compounds, but that's not necessarily the case if the dry coffee dose was really high or if the brew weight was low. The Specialty Coffee Association actually has guidelines for where the best crossover point is between TDS and extraction yield. So they say that the optimal TDS range is between 1.15% and 1.35%. And the optimal extraction range to go with that TDS is 18% to 22%. Now, that chart has been around for a while, and it's actually been contested a little bit in more recent years. And I can say for myself that not only have I had excellent brews that were well extracted, that were 1.6 TDS and 24% extraction, but also that the whole idea of a TDS number being what you should shoot for has been debated a little bit. And there's a reason for that. The reason is that TDS alone does not tell you how your extraction went, which is why we have this formula. But if you have a really low quality grinder, imagine one of those whirling blade grinders. You could put a lot of coffee into your brew basket, ground up really inconsistently, and brew your coffee for a very long time and get a high TDS. So that's going to be a really strong cup of coffee. It's probably going to be sour and bitter at the same time, but you got a high TDS. So TDS isn't the only thing that matters. And extraction range, the percentage 18 to 22, isn't necessarily the only thing that matters if you have a really bad extraction. So whether or not an extraction is good or bad is left up to the palate rather than just saying that it fell within this range. So that's really important to know. So the ultimate judge of whether or not the extraction was good is how it tastes to you. Meaning we can profit from this discussion about how extraction is calculated and learning how it impacts our brewing without having to have all the tools and making the calculation every time. Now I'm going to mention a few things that I've noticed since I've gotten a refractometer. I've been measuring my brews, and I think they might be, hopefully, they might relate a little bit to your experience, or it might shed some light on some things that you've experienced in the past. So the first thing that I noticed that I was really surprised by, and I haven't seen anyone really write about this as far as I know, is that the way that the coffee is roasted will impact how much total dissolved solids you have in your cup. So I had an experiment where I had it was a delicious natural Gesha coffee and I had 3 batches of it. One was roasted by my dad and I, and the other 2 batches were roasted by a friend of mine. And I brewed each batch and did the extraction yield measurement, and each different batch actually had different TDS, which led to different extraction yield, even though I used the same amount of dry coffee, the same water temperature, the same approximate brew length. All of that was the same, but the TDS differed. So depending on the way that the coffee was roasted, there was an impact on how much coffee compound ended up in the cup. If you've ever experienced this, I would love to know about it, but I think that there's something to learn there with the way that we roast. And how good a roast tastes. Because if we're doing something in our roast that leads to a low amount of TDS or a lower extraction, that's probably not going to taste as good to us as something we would do in our roast that leads to a lot of coffee compounds being released in our cup. So it seems like coffee solubility is definitely impacted by the way that we roast. One final example I wanted to mention is how coffee to water ratio can impact extraction yield percentage. So when I started measuring extraction, I was using a 16 to 1 coffee to brew ratio, which was what I had used for years, and it tasted about right to me with the equipment that I had. And I noticed that a lot of people online use a 17 to 1 or an 18 to 1 brew ratio. So I switched from 16 to 1 to 17 to 1, and that means using 17 parts water to 1 part coffee instead of 16 parts water to 1 part coffee. So more water, less coffee. And when I switched to that ratio, my extraction yield increased on the brews that I was making. And to my surprise, the coffee didn't taste weaker, but it tasted clearer and more flavorful. And there's a lot of reasons why that's true, but just if you go back to our formula, it makes sense that extraction yield would increase if TDS could be held constant while we increase total brew weight. And that's what happened when I moved from a 16 to 1 to a 17 to 1 ratio. And I think that's because there's more water per coffee ground that is extracting oils from that coffee ground, which means that you can get more out of it. So those are just 2 things that I've noticed out of several, and there's going to be follow-up videos to talk about more of that. But I'm really curious to know what all of you think about this information. Maybe if you're familiar with extraction yield and I got something wrong, please let me know. We can all learn from that. Or maybe you haven't really looked into calculating extraction yield for your brews and you have questions. If so, please let me know in the comments and we can chat there. Ultimately, though, remember that understanding the fundamentals of brewing and how extraction can be calculated can help us improve our brews without necessarily having to use the instruments ourselves and take those measurements, because our palate can guide us. So, enjoy your brewing and let us know what you learn. Thanks.